Hello guys, this is Paul McWhorter with TopTechBoy.com, and are you ready to rumble? Because we're here live. Okay, let's see who we have in the house today. You guys leave a comment so I can say hello to you, who you are, and where you're from. So let's see what kind of audience we have out there. As you are doing that, I will of course need you all to pour a nice tall glass of ice cold coffee. Okay, Andrew's saying the audio is a little off. Okay, we'll keep going. All right, we've got Colin, we've got Daryl, we've got Cyril, hello, Ken, we've got Brian, Daryl, I'm on the big screen. Okay, Daryl. Levi, hi Levi. The Wise Ninja, hey, haven't heard from you in a while, Wise Ninja. Welcome back. Mark, welcome. 6 Knots from Australia, the land down under. All right, Ken from North and Cold Canton, Ohio. Michael Avision from Texas. Wild Bill from Huntsville, Alabama. Brian, let's see. Brian is saying that the audio is out of sync. Let me see here. Let me see if there's anything I can do. Audio out of sync. Give me just a second. Let me see if there's any. Is the audio clear or it's just out of sync? All right, let's see what we can do here. Give me just a second. Okay, is that making any difference or still okay? Still not okay. Audio is clear but out of sync. Okay, audio is clear but out of sync. All right, let's get back over here. This is probably about all that I'm going to be able to do, because I'm not sure. Sometimes it's on the way to the live stream and there's not much that I can do there. Video is ahead of audio. Video ahead of audio. Okay. All right. We've got some Australians here. That's good. Like an old martial arts. Okay. Okay. I understand. Let's see. I'm doing I'm 12 and doing the Arduino tutorial. Levi, that is really great. That is really incredible if you're doing that. I think I am seeing that. You guys, give me just a second. I am going to try to see if I can restart this studio. So you're going to lose me for about 5 seconds and then I'll be back. Okay. So you're going to lose me for about 5 seconds and then I'll come back. Okay. Okay. So I think, did you guys get me back? All right, do you guys have me back? Is it fixed? Okay, I'm sorry about that. But what I had to do is I just turned the studio off and then restarted the stream, and now we are good. Okay, what a distraction. Okay, let me get back. VJ, hey VJ, good to see you. Arlo, it's good to see you. JC, Mark, the Wise Ninja, 6 Knots. Hey Lee, it's always good. Ullman, all right, great to have you here. Lowell Yates, all right. Ian, Dennis, okay. Hello, Dennis, Mark, Levi. All right, so we've got everyone here. I think I need to get my background. Connected again. I lost a few connections along the way. And let's see. Okay, so off to a little rocky start here, but we'll recover. I'm trying to see if I've got my camera. Yeah, it's dark back there. So you guys in the background, you'll be able to see over time. You will be able to see the lights coming on. It is 6 in the a.m. here. It is 6 in the a.m. here, and so it is still a little bit early. Okay, let's see. We've got Donald. We've got quite a few of Australians here, so welcome. You guys know that I really love Australia. I've been there a number of different times, and so really, really love going down there. Hey guys, what we will be talking about today is we are going to be talking about the future direction of the Raspberry Pi lessons. Also, I have a new studio cam. I'm not sure I've shown you guys that. Let's see if I can connect to the studio cam. It's not working right now, so we'll come back to that. We'll come back to that in a minute. Okay, you guys, let me know how many of you guys are taking the Raspberry Pi lessons or checking in with them, or any of you guys working on the Raspberry Pi lessons with me? And I'll give you just a second to answer that, and then we'll see. Okay, wow. 1 p.m. in Brisbane, Australia, 2 p.m. in Sydney. Yeah, I've been to Sydney. I've not been to Brisbane. I went to New South Wales. I went to Adelaide. I love Adelaide. So I pretty much went all over Australia, but I don't think I made it over to Brisbane. Okay. Yeah, so Levi's only working on Arduino. Well, Levi, when you get done with the Arduino, take the Raspberry Pi. Ken says yes. Lee says yes. Mark says yes. Donald's taking the Pi lessons. Dennis, let's see. Scott says I've not been doing the Raspberry Pi lessons. Okay, Rob's trying to catch up. All right. Well, what you guys know that are taking the Raspberry Pi lessons, we kind of on our kit, we've gone through most of the components in the kit, and then finally we sort of saved the camera for last. And what I showed you guys how to do is I showed you how to get the camera working on Bullseye on 64-bit, and then I showed you how to work with it inside of OpenCV so that you're not just firing up some program that, you know, shows a video from the camera, but you're in there playing with your video and manipulating your video frame by frame by frame. Okay, so that's kind of where we got to. And then in the last couple of lessons, it's been a little bit tedious, but I've shown you how to understand what a frame coming off the camera is, and understand that as a data set. So I kind of broke it down to when you grab a frame, you're really grabbing a two-dimensional array of rows and columns of pixels, and kind of got you thinking about how you can go in and break that down and either analyze that data array or manipulate that data array. Man, we've got a, hold on here. We've got a, would somebody take care of that guy for me? Okay. Let me see if I can. Okay, we had a message. We actually had to ban someone, so that doesn't happen very often. But that one we had to ban, so sorry for the distraction. You guys that are moderators out there, keep your eyes on that. Okay, so I am trying to get this other thing set up here. All right, there we go. Okay, so we're now thinking of our frame that is coming off the camera as a data set. And as we think of it as a data set, then what we can do is we can go in and start analyzing it or manipulating it. Okay, so let's see. Let me look at your comments now. I'll go in. I'm going to try to answer some questions, and then what I'll do is I'll go in and kind of show you where we're going with some of the lessons. Okay. Would like to do a project with the Raphael kit rotary encoder at some point. Yeah, I agree there. Is there a kit that sell the Pi? Yeah, the Pis are hard to get right now, so if you don't have one, it's kind of hard to do the Pi lessons, but I'm hoping in the next few months the availability of the Pis will come back. Okay, thank you, Steen. Watching from Dallas, John, welcome. Harrison, hey, haven't heard from you in a while. Welcome back, Harrison. Victor Soto from Corpus Christi. All right. Brooklyn, New York. Have you worked on RTSP? Yes. And probably we will be going either like the RTMP or RTSP. We will be going that direction with the Raspberry Pi before this is all over with. All right, so now let's see. Let's talk about some of the directions that we will be going. Excuse me. Some of the directions we will be going as we are moving forward with these lessons, okay? So I'm going to come over here and I am going to show you a different view, and then I'll show you kind of some of the lessons. So I'm going to come up, and this is a program that I'm running on. And what's one thing that you notice about my little Raspberry Pi there? Oh, look at that. Okay, so I'm running this program. I'm going to have to line up these windows a little bit so that you can see everything. Also, I'm sorry, I've got a little something in my throat. All right, so we're going to get like that. And now I'm going to bring this over here. I need to do one other little thing here. Give me just a second. Man, my audio-visual studio stuff is just not ready for prime time today, is it? I've got to get that one window out of the way a little bit so you can see everything. Give me just a second. Okay, there we go. Got that out of the way. Now I'll get this where you can see it. All right, then call up this, and call up that. Okay, so here is what I want to show you, right? What we're thinking of now is you're looking at the frames that are coming from the Raspberry Pi camera. And so, hey, Wendy, how are you doing? How are you doing, Wendy? Welcome back. Haven't heard from you in a while. Hope you're doing well, Wendy. Okay, so what we're doing is we're grabbing these frames, and now we're going to start analyzing these frames. So what I want to do is I want to look for an object of interest. And so my object of interest is going to be this yellow cap. But you can see it's not finding it very well, but I can come over here and I can kind of tune in on my object of interest. And I can sort of tune in on it like this, and then I'm going to tighten up on it. And then what I want you to see is, so I'm grabbing the frame, and then I'm telling it what I'm interested in is this yellow cap. And then up here, I create a mask where I ignore everything but my object of interest. So if it is my object of interest, the pixels are white and everything else is black. And then what I'm doing is I am taking that mask and I am ANDing it with the original frame. And then what I get is I get this image, which is everything taken away except for my object of interest. Then once I have that, then what can I do? I can build a contour. I can say, okay, circle the thing that is left and then do a bounding box around it. And then what can I do? I can track the object of interest. Okay, I can track the object of interest. So how is that? Does that kind of make sense where we're going here or not? Okay, tell me what you think about this. Is this pretty neat? Somebody give me some feedback. Okay, cool, Andrew says. You guys are being quiet out there. Okay, good stuff, Colin says. Interesting, Samuel. All right. And I want you guys to look at my little camera here. Can you see my little camera in the inset image? Okay, the Wise Ninja likes it. Okay, so you see I have trained it in front of you on my object of interest, and I boxed it and I'm tracking it around. But somebody tell me what would be the really cool thing. Is there a way to make the program that auto-tunes itself? So, well, you would have to kind of figure out what you were looking for. Hey, Wendy, yeah, okay. It will be neat to see it follow you around the camera. Yes. Okay. So what do you notice here? You notice over here that I have the camera mounted on a pan tilt bracket. And guys, if you're interested in the pan tilt bracket, I've got a link down in the description below. Okay. But what I'm going to do is I know OpenCV knows where my object of interest is. So what should I do? I should start actually tracking it. Okay. So you guys look at that little inset image. Do you see that? We can go up, we can go down, we can go over. Okay. Do you guys see that? Yeah, track balloons. That's pretty funny. Okay, so you see, that is pretty darn cool. So you guys let me know what you think about that. Oh, we kind of lost it there. All right, I'll stop that. Okay, is that pretty neat or what? How many lines of code? All right, that's a good question. How many lines of code? We'll look down here. It looks like about 119, but it's not that hard because a lot of it is just setting up those track bars. And so a lot of the track bars are just kind of copy and paste. Servo with a laser to point and shoot targets. Yeah, I've actually thought about that somewhere. I've got like a 6-watt laser down there, and I thought you could define an object of interest, and then you could blast it if you wanted to. Yeah, this is kind of getting into artificial intelligence. If you lose the object of interest, it just stops. It doesn't track if it doesn't see an object of interest. That looks like an awesome project. Yeah, that's where we're going. 119 lines of code. Well, but you see, it's not that hard of coding. It's really a pretty straightforward algorithm that, first of all, you have to find your object of interest. Then you've got to box it. Now, you know where the center of the frame is, and you know where the center of the object of interest is. They're not in the same place. That's an error. And then you just adjust your servos to drive the error to 0. So it's really, I think when you guys get into this, you're going to see that it's pretty, it's pretty straightforward, and you'll be able to do this on your own. I mean, it's not like crazy math. I will show you how to do this. And I mean, you can see the first 30 lines of code are just getting the camera set up and getting the servos turned on and things like that. Okay, now you can see that for this case, this is just sort of dabbling, putting our toe into artificial intelligence, because how do we define our object of interest based on color? So we're tracking on color. And so that's kind of like a little bit of a simple artificial intelligence thing. But then here in this next one, we'll try to kind of go to the next, the little bit of next level of artificial intelligence. So I'm going to come here, and this time I'm going to run it, and let's see what happens. Okay, I'm going to run it. And now what is it doing? Okay, now I'm what? You see, I'm recognizing faces on the Raspberry Pi. Now, one of the things that you can see that's happening is I've gone from about 30 frames per second to 6 frames per second. So you see that we're really at this point starting to kind of challenge the computation resources of the Pi. But you see, you can do face recognition and you can do eye recognition on the Pi, and you can do it at about 7 frames per second. Now, if you want to go faster, you can come up here, and instead of 1280, let's say you went 640. Instead of 720, you went 360. You made the frame smaller, and then if you make the frame smaller, the AI part of it is a lot easier. And so you see now we're operating at almost 20 frames per second, finding a face and finding eyes. How cool is that? Okay, now if I can find the face, what would be the next thing? What would be the next thing that would be interesting on the face? Okay, somebody tell me the next thing that would be interested on the face. Okay, yeah, what it would be interesting is now turn the servo on. So let's see if I can come over here and turn the servo on the face. And that was not the right program. Let's see. Let's try to run this. Let's see it. Okay, so you see now as I move, it is tracking the person. You see now as I move, it is tracking the person. And I can go up, I can go down, I can go over, and now it is tracking the person, and it's doing it at about 7 frames per second. Again, if we wanted it to be a little bit snappier, we could come in and we could make that image smaller. And so let's say that we went 640 by 360. Okay, and now you see it's just really, it's operating at 24 frames per second. It kind of lost me there for a second, but we'll move around and it is tracking me. Okay, guys, okay, Arlo wanted to see 640 by 480. Okay, I can try that, 640 by 480. Let's see what happens. Is that like, that's like a more square picture? Okay, there it is. Yeah, and that is operating pretty quickly, 20 frames per second. The one thing for this face tracker, you have to kind of be looking at the camera. You see as I look away, it doesn't recognize the profile. It just recognizes when you're kind of looking at it. Okay, so that is kind of the direction we're going. Did you buy the autofocus camera? Bill, this is just the camera that came. It's just the camera that the little Raspberry Pi camera. It's nothing fancy. So you guys give me some feedback. Is this pretty cool stuff to be able to, on your own, learn how to identify objects of interest from the Raspberry Pi and then do something and actually track them? Because there's kind of some fun and interesting math that'll go into this. Hi, Mag, welcome. Charles, welcome. Andrew says, could you use PID for the servos? That would be pretty neat. Actually, yes, Andrew. And the easiest way to do this control algorithm is, again, you're thinking about two things. You're thinking about the center of the frame and you're thinking about the center of the object of interest. Well, if the object of interest is to the left of the center of the frame, you just correct by 1 degree. So you just try to drive that error out. Change by 1, change by 1, change by 1, change by 1 until the error goes away. Okay, so if you're this far away, you go 1, 1, 1, 1, 1, 1, 1, 1, 1. That's like the simple-mindedest control system that you can use. But what would be smarter, as Andrew pointed out, if you did a PID controller where you're doing proportional, where rather than moving the camera 1 degree at a time, you look and you say, well, if I have a 30-degree error, I'm going to move the first time, I'm going to take half the error out. So the first time I'm going to move the camera 15 degrees, and then 7 degrees, and then 3 degrees, and then I'm there. So you get there quickly because your correction factor is proportional to the error. Now, PID means proportional, integrated, and differential. And on a simple thing like this servo, really all I'm doing is just the P, the proportional. I'm not trying to fine tune with the I or the D. So that is the direction that we are going. And then what we will be doing is let's see, what are you doing? Okay, then what we will, Andrew, what I just showed you was proportional. Okay, it was proportional. Each step I'm taking half the error out. And so let's watch that again. Man, Andrew, it's like you're giving all the secrets away of the future learning. So let's see if we can dial in on this thing. And so I got to kind of tune it. There it is. That looks good. Okay, now I'm going to get these out of the way. Now I'm going to turn the servos on. Okay, now watch. When I move this, do you see how quickly it's moving? And then you see how it's moving quickly at first, and then as it comes down, to the end, it's taking smaller steps. So I don't know if you can see that, but you see I've actually got I've got that proportional control in there. But what we're going to do is we're going to be going through this step by step by step. So what's the first thing that we're going to do in future lessons coming up? How do you track an object of interest? Then I'll start showing you, okay, how do you do something on the Raspberry Pi where you can find a face? And then once you know where something is, kind of going through the smart math that allows you to move the servo to keep track of it. And really, when I draw it out on a piece of paper, it's not as hard as you might think. It actually sort of makes it actually sort of makes a whole lot of sense. It's not as, I don't think the math is going to be as complicated as you might think it's going to be. Okay, let's take a few minutes and take some questions here. You guys give me some questions on this. Does this sound like a pretty interesting direction to be going, or give me some feedback here? There's the most excellent iced coffee. Ah, yes. And I also have some hibiscus soda this morning. I make my own hibiscus soda, carbonated, no sugar. It's very refreshing. Someday I'll have to show you guys how to make that. Spanish intelligence agency would have loved this in the Casa de Papas series. Okay. Use your perimeter, use on your perimeter alarm. Yeah, one of the things that you could imagine is you could have the PID sensor and you could only turn the camera on like when you see something in the field of view, and then you could track it. It could be pretty interesting. Let's see, let me go back and let's see if it's getting light outside. It's starting to kind of get light. Also, let me see if my studio camera will cooperate now. And we had some audio-visual problems today, didn't we? No, studio camera's not cooperating. Okay, so you guys tell me what you think about this. John Doe, very awesome, good. Andrew, I've got to restart this series of lessons. Sadly, I've been busy, but I've got to get back to these. You're not doing your Raspberry Pi homework, Andrew. Come on, let's get back with this. Are you using metal or plastic gear servos? I think these servos are plastic, but these are really, really good servos in here. And they have a clutch, so if you crash it, you don't necessarily strip the gears out. But they are nice servos, and you see that they come in and they're very stable. So I'm happy with the servos that are on this. Okay, James likes the tilt and pan. Good, John. If topic, how often do you do live charts? I'm thinking you probably mean live chats. You know, I haven't been doing them in a while because I haven't had good internet and good power. But now that I have good internet and power, maybe, we could try to do one once a month, a couple of months. I don't want to do more than you're interested in. I don't want to bore you. So I always want you to kind of be looking for more. So you guys let me know. Would you like to see like one live chat a month or 2 live chats a month? You guys give me some feedback on that. Okay, so Dr. Dave says very good. That's good. Yeah, the clutch is cool. It helps you from damaging these things. John 4 is actually Skipper 480. Not sure how to get signed in to use my username. Okay, and chats, yes. How long did it take you to become proficient with coding? I feel like I understand the lessons, but then struggle to do anything on my own. Okay, in coding, the proficiency in coding is not so much about the coding, it's more about the thinking. Okay, writing the lines of code is easy. So what I always recommend you do, get out a sheet of paper and draw things out on paper. Think through it. Think about the problem analytically about what you're trying to do, and then the coding will be easy. But the number one problem that I see in young coders and in new coders, like when I was teaching in the high school, I would give an assignment and man, those kids would run and they would grab their kit and they would plug it in and they would start typing without thinking. And then they would be trying to fix things and do things, and they were working on the code sheet instead of working on a piece of paper. So my biggest advice to new coders is draw out your algorithm on a piece of paper, okay, and sketch out what you're doing. And not writing lines of code, but drawing a picture, okay, like drawing a picture of what you're trying to do. And so, like, let's see, let me just kind of give you an example of that servo. That was like a kind of like a really complicated program, right? So let me see if I can get over there, kind of trying to do this on the fly. But think about that servo, all right? And then let's think how I coded up that servo. I didn't just jump in and start coding. What did I do? I started by drawing, okay? Here's my frame, okay? And then, can you guys see that? Yeah. Then what is this? This is the center of the frame. Where is the center of the frame? Well, it's the display width divided by 2, comma, the display height divided by 2. Then what else do I have? Well, besides the frame, I have my object of interest. And the object of interest, I know where the center of the object of interest is. That's here. And I know that because doing my contours and stuff, I can get that. And that's x, comma, y. All right. Is the center of the object of interest at the center of the frame? Right. What do I want? I want this in the middle of the picture. No, it's not. I have a what? I have an error. Okay. And what is that error? Well, it's the x here minus the x here. So error is equal to x minus display width divided by 2. And then what do I do to get rid of the error? Well, if it's positive, I subtract a degree. If it's negative, I add a degree. Okay, so you see right there in 3 minutes I drew a picture, and that picture is going to make it way, way easier for me to write the code. So that is my biggest suggestion. Draw a picture before you jump in and start trying to code. Okay, let's look. I'm going to try to catch up on some of your comments. How long did it? Okay, it took me, I coded, it didn't take me long to code because in the first 20 years of me being an engineer, I didn't code, but I thought about problems analytically. And because I could think through a problem analytically, when it came down to writing the code, you know, I didn't have any problem. Okay, Ken, you never bore us. Thanks. That is really nice of you, Ken, to say that. And then VJ Sci-Fi becomes reality. Yeah. Two a month sounds good. Okay, that could be something we could try to do every couple of weeks. You know, a couple of things that you know we might talk about in the future is I've been playing around a little bit with home automation, and we kind of might talk about the ideas of home automation and where that is and where that's going. Another thing is I bought the high resolution Raspberry Pi camera with a bunch of lenses. I might kind of see what's going on there. I haven't plugged that in yet, but I want to kind of see, is that high resolution camera for the Raspberry Pi really worth it? Does it really give you better images? And then also what I'm going to be wondering is, does the Raspberry Pi really have the horsepower to handle those bigger images coming off of that high resolution camera? So those are some things that we might do in the future. Those are some things that we might do in the future for a Raspberry Pi or for a live stream. Okay, I was wondering in regards to, okay, let's see. I'd like to see OpenCV reading a gauge or analog clock maybe. Okay, we can think about that. That would be interesting. So OpenCV reading a gauge. Okay, so like looking at an analog dial and trying to understand what the data is. That would be interesting. I was wondering, this is in regards to Arduino. Are you able to create a video to show program? I have not done the RFID tags on the Arduino. I think there's RFID on the Raspberry Pi, and we might do that lesson after we finish the up the video ones that we're doing. I don't understand what exactly comes with the items you suggest us to purchase. How many spare servos? And it's some founder Okay, if you're talking about the pan tilt head, the pan tilt head comes with everything you need to make it work. Okay, it is possible to damage a servo, whether it came with the Sunfounder kit or it came wherever. Servos will get damaged, and so what I'm just saying is that if you have a few spare servos laying around, that's a good thing. When I put the Sunfounder pan tilt hat together and I turned on my control system, I hadn't put limits on it, and the control system was going the wrong way, so it like slung the camera in a very hard direction down, and then it hit the base, and I did damage one of the servos. Okay, so it is possible to damage a servo when you're doing a control system. I should have been more careful. It was my fault, but that's what I'm just saying. If you have a couple of extra servos laying around, that's not a bad thing. Okay, I hope that answers that. John says, this is crazy. I've been reviewing your new Arduino series this past week while attending a class here in DFW. Okay, well, hopefully you'll stick with it and keep following these lessons. Do flowcharts? Yeah, Ken. Sometimes I don't so much do a flowchart as I draw a picture. Like I draw a picture, okay, here's this, I'm here, I'm dropping this. I just try to draw a picture, I try to label it, and then I try to write some math. So draw a picture, label it, write some math. And then after that would sort of come the flow chart thing. Leah, I agree with you. Practice, practice, practice. And what I would say is, like, if I give you a homework assignment, try to do it and try and try and try and bang your head, bang your head, bang your head, get frustrated for 2 or 3 hours, then look at my solution and then go back and then do it by yourself without watching me do it. And if you do it, then things will start coming in. Things will start working. Okay, let's see. We've got Brian saying, always think first. Yeah, Brian, thinking first. That's good. Yes, I was writing out my algorithm for binary counter on paper and I figured it out. That's good. Are you suggesting to write the code out on paper or pseudocode? No, I'm not suggesting pseudocode. I'm saying that, like, if I have a servo, what am I trying to do? I draw a box. This is the frame. I draw the object of interest. That's the object of interest. Is it where it's supposed to be? No, there's an error. Mathematically, what is the error? It's this point minus this point. What do I want? I want the error to be smaller. So, pan tilt equal pan tilt minus 1. Then it clicks over. Is the error smaller? Yes. Is it still there? Yes. So what do? Error is error minus 1. So you see, I draw a picture out having nothing to do with code. I label it. Then I start writing some little math relationships. And then I take that picture and I do the code. I hope that makes sense. Okay. Yeah, so then let ChatGPT do the coding. Guys, I've been wasting way too much time on ChatGPT, and I finally just said I'm not going to do anything else there because it's a disruptive technology. It's going to turn the world upside down. A lot of people are going to find themselves without job. There's going to be just this I think the ChatGPT is like one of the most disruptive things in the world out there for like the last 1,000 years, like maybe the biggest disruption to the world since the invention of gunpowder or something like that. But what I want to do is I want to stay tightly coupled to reality. So things like, I go outside and I work in the garden, I'm growing rabbits, I'm building little projects on the desktop that do interesting things. You see, I'm doing things that is focused in the real world, and I want to have real world hands-on skills. But if someone is just a programmer, then I think ChatGPT is going to possibly put a lot of people out of work. And there's also, like, besides ChatGPT, there's another version of ChatGPT where I think Microsoft bought GitHub, and GitHub is where all the code in the world is posted. And then they've turned their artificial intelligence learning algorithm loose on all of the data that exists in GitHub. And now they have a very, very smart AI system that can code anything. Okay. And so that is really, really, really going to be disruptive, I think. Let's see. John says, I'm trying to catch up with the comment. I actually write down all the sketches you post. That's good. That's always a good idea. Buy a notebook for every, yeah, I think buying a notebook is really good. And I really do. I really try very hard to keep my notebooks, up to date, and I draw in them, and I try to document the stuff that I'm doing on paper. Okay. You don't have to write pseudocode. Yeah, I'm not a big pseudocode guy. I am more of someone who just likes to, draw pictures. And I also tell my math students this is like, when you read a math problem, draw a picture it, label it, and then write down what you know, and then write down what you need to know. And so I think there's logical ways that you can do things that make math and programming a lot easier. Yeah, let's see. Man, it's kind of hard for me to do these comments. They sort of jump past me. I'm saying that after you tried to trouble, yeah, okay. Fisherman, okay, I missed the fisherman. I'm sorry. Oh yeah, there's some fishermen coming right there. Okay. Starting to get light out there. There's a boat. Yeah, the Pi Pico kit has RFID in it. Yeah, and on the Pi Pico, I will probably be doing the RFID. I will be getting to that. And then let's see, my 180 turned into a 270. Okay, I haven't tried that. What would it entail in programming fingerprint to create digital write? I do not know on that. Okay, how do the servos know which way it's pointing? Is there a potentiometer inside that is no? BBF, these servos don't know where they are. Okay, but what do we know? We know the center of the frame, and we know the center of the object of interest. Are they in the same place? No. Since they're not, Raspberry Pi tells the servo, move. Raspberry Pi tells the servo, move, move, move. Okay, so it's Raspberry Pi telling the servo. And how does Raspberry Pi know? How does Raspberry Pi know? Because it's looking at the picture. So hopefully that makes sense, BBF. Okay. Yeah, you're right, Colin. ChatGPT does write Arduino code, but I don't recommend using it. Is there a Raspberry Pi simulator? I do not know about that. Hey, BBF, yeah. Let's see, ChatGPT, the catalyst for all the software engineers being fired. Well, I think that life has always been hard for software engineers because by the time you master a program, it becomes obsolete, and you're constantly chasing the new algorithms. You're constantly chasing the new programming languages. And so life as a programmer has always been one of fighting as hard as you can to not be obsolete. Okay, fighting as hard as you can to not be obsolete. But I think now it's going to a whole new level where, with these software tools, with these algorithms like ChatGPT and the one that's connected to GitHub, you're getting to the point of, wow, something that took 20 programmers before might take one sort of overall coordinator to bring things together. So I think we're going to see crazy things in the world in the next year or so. 100K layoffs this year, yeah. And I think a lot of the layoffs now in these high-tech companies is that it was just silliness. There were just a lot of people sitting around doing nothing, going to various useless meetings and, sitting around and, drinking Tai Chi or something like that. But I think that the layoffs that have occurred so far is just a big fat, bloated organization with a lot of people that just weren't doing anything in particular, sort of like at Twitter, and he lays off 80% of the people and no one even notices or whatever. But that's not what I'm talking about. There are hardcore hardcore people who are cranking out really sophisticated code. And those are the people that I think are going to be, are going to be on the chopping block. And that's going to hurt because those are hard workers that have poured a lot into their job. Will ChatGPT do your homework? Yeah, Harrison, ChatGPT would do just about any of my homeworks. I asked ChatGPT to write 2 programs, one that would encode data in a blinking LED and the other one that would detect it and decode it. And it wrote the 2 programs. It was pretty amazing. Can you ask ChatGPT to make a better version of itself? I've had some interesting conversations with ChatGPT, and that's like what I was saying. I waste too much time on it. But like I was talking to it about an esoteric topic way back in history that was very specific about an individual who lived in 1840 that no one would have ever heard about. And I had an interesting conversation with ChatGPT about that person. And then and they had a certain position. And then in the interaction with them, me referencing other data, which ChatGPT could look at, ChatGPT changed its mind and said, yes, actually, this person probably never did really adapt to, civilized life. Hey, Kevin, wow, thank you. Where did my bell go? I wasn't ready. I don't see my bell. Wow, Kevin, I really appreciate it. Ah, there it is. Okay. Hey, thank you, Kevin. Really, really appreciate that. So I'm chatting with ChatGPT about whether this certain person ever acclimated back to Western civilization. And ChatGPT said, oh, yeah, he had. And then after talking to him and then having him look and dig, yeah, he says, probably this person really never did adapt to Western life. So ChatGPT changed its mind based on the conversation. Then I asked ChatGPT, okay, this new understanding that you have, is this just good for this session? If I close this session and someone comes back, are you going to utilize the knowledge that you now have based on your interaction with me, or do you just go back to your old answer? And it said, well, right now it goes back to the old answer. It doesn't retain gained knowledge from logical interactions with people. And ChatGPT agreed that if it would retrain itself based on a more deliberate analysis from interacting with a human, it would continue to grow in its capability. It agreed that it would be better if it did things that way, but I don't think it has the ability to change itself at this time. Okay, let's see. Do you think that electrical engineering is still a safe bet for the future? Yes, but what I would go into is I would go into hardware. I would go into control systems. So like if you think of power distribution, you're always going to have people managing the grid. Okay, if you think about control systems, they're just, you've got to have your hands on the hardware. And so any job where your hands are on the hardware, I think it's more future-proof. And hardware includes toilets and circuit breakers. I mean, plumbers, electricians, diesel mechanics, wind turbine technicians, power distribution, that if I was going to be going into the high-tech world, I would want to make sure that my hands are on the hardware, if that makes sense. What should one learn as an embedded system engineer? Well, you need to learn things like Arduino and Raspberry Pi and all those type classes. What about mechanical engineering? Andrew, I know you want to be a mechanical engineer. I just don't like mechanical engineering. Those jobs are way more boring. They are way more boring. And I've had 2 students of mine that went into mechanical engineering, and both of them came back to me and said, you were really right. I should have been electrical engineering. And both of them, even though their degree was mechanical engineering, their work now has moved back to electrical engineering. And so, as an electrical engineer, I did nanotechnology, I did AutoCAD. I mean, you can still work on that stuff, but it's just electrical engineering is a better core fundamental set of skills. Okay, do you have any plan to have a lesson on audio for the Pi? That is not something immediately in the plans right now. What's the best way to learn circuit board building? I do not know on that one. Can you make video series on Linux terminal related stuff? I have a few videos out there that's sort of like Linux in one session where you can learn kind of the basics, you know, in an hour. And so check the channel out for that. Okay. Lots of crossover in classes skills. Yeah. Brian, I mean, the thing is, if you know differential equations, you can do any field of engineering, because engineering is really applied math. It's applied differential equations. It's just that when you go into electrical, you get such like the control system, and you get the programming, you get so much more stuff in your education than you're going to get in the mechanical. Okay, is 30 years old too old for engineering? Absolutely not. You're never too old to move into engineering. Let's see. Yeah, as a mechanical engineer, I did PLC control and data acquisition. Yeah, Ken, and that's a lot more like what you would think would be electrical type of stuff. And so that is what I am thinking. Would you make a series? Probably not going to do any RTOS at this point. Okay, guys, we are kind of coming up towards the end of the hour, and I think I've got some people coming in downstairs that I'm going to have to go talk to. So this will probably be a good place to kind of sign off here, guys. I apologize. We got off to a really rough start with the audio not working, and then a couple of my video shots not working. And so next time I'll try to have the studio a little bit more tuned up before I start the live stream. But hope you guys enjoyed it. If you do, you know, give me some feedback. Somebody said maybe a couple of live streams a month. I don't want to bore you guys, but I do enjoy doing them. And if you guys enjoy them, we can try to do 1 or 2 a month. Okay, guys, I think I will let you go now. Remember to like and share this video. And remember, more engineering and fewer silly cat videos. Paul McCorder with TopTechBoy.com. I will talk to you guys later.